In this video, we'll have a bit of an intro to filtering, particularly digital filtering using digital signal processing. But before we get to the digital filtering, think through this analogy with me. What if we had a whole bunch of soil, and that bunch of soil contains some fine granules of soil and some really coarse granules of soil, maybe some rocks and things as well. And we want to separate this soil out based on how coarse or fine it is. One thing that we can do is we can go through with some tweezers and pick out each grain at a time, but that would be ridiculous. We wouldn't want to do that. But what we could do is have some sieves, some soil sieves. And so here you see a picture above. We dump a whole lot of soil on this soil sieve. The soil that is finer in granularity than what the sieve is will fall through and into the wheelbarrow or whatever we have there. The soil that's not finer will be trapped on top. Some soils are too large to go through, so they're rejected. Some soils are small enough, and so they'll fall through. This is a little like what we're doing in digital filtering, but with frequencies rather than granularity of soil sizes. So filtering allows us essentially to filter out frequencies or bands of frequencies that we don't want. And we're doing this in the frequency domain, not in the time domain, or the soil domain for that matter. It's one way that we can reduce noise in the system. For example, if there's particular frequencies that there's noise that they're inducing into the system, maybe like a power line 50 hertz hum frequency or something like that. And we've essentially got 4 different types of filters that we're using. These are low pass filters to filter out higher frequencies, high pass filters to filter out lower frequencies. They allow the higher frequencies to pass through. Band pass filters, where we have a certain band of frequencies that we pass through and anything outside that are rejected. And notch or band reject filters, where there's a certain band of frequencies we reject and cancel out. Now, we can go back to our dirt analogy before, and rather than just having one sieve, we could have multiple sieves. We could have a coarse one and a fine one. And to me, the soil that will go into bucket A, that is a bit like having a low pass filter, where most of the smaller granules are removed and we just have those larger granules there that will go into that bucket. Everything that doesn't go through that sieve, you can just tip into the bucket. For the B is a bit medium, and it's a bit like a band pass filter. There's certain bits of soil that are rejected because they're too big, and certain bits of soil that go through the next sieve because they're too small, and we've got some in between there, medium-sized granules. And then soil at C is really small ones. It's like a high-pass filter where all the larger soil has been rejected by either the first sieve or the second sieve, and we have a bucket C that's got all the fine soil in it. Nice way of thinking in an analogy form about these different filters. Now, one form of filter that's commonly used for DSP is the FIR filter, the finite impulse response filter. Basically what we do is we multiply different samples by a whole lot of different coefficients. We add all those multiplication values together, we sum them up, and that gives us our filter output. Now, there's a whole lot of maths associated with this, and we're not going to go into any of the mathematical detail. Suffice to say that we've got all these coefficients that we need to tune somehow, and those coefficients are what specifies what type of filter we're using. A band pass, a band reject, a high pass, or a low pass. Nice thing is that something like MATLAB can compute these coefficients for us and allow us to generate a filter for us, because they've got filter design software within MATLAB. To do this though, MATLAB will need a few parameters. So it'll need to know, for example, what the filter type is. Do we want a band pass or a high pass, low pass, whatever. It also needs to know some things about cutoff frequencies. When do we want to, if we've got a low pass or a high pass, when do we want to actually start doing that filtering? What frequencies do we want to filter off? And we'll also specify things like the amount of ripple that we're allowed to have in the various signals, both at the reject band and at the pass band.